The conduction of electricity varies in different states of matter: solids, liquids, gases, and a vacuum. Let's explore how each state allows or restricts the flow of electrical current. 1. Solids. In solids, electrical conduction occurs through the movement of charged particles, primarily electrons. 1. Solids can be classified into three categories based on their conductivity: conductors, semiconductors, and insulators. Conductors. In conductors, such as metals, the outermost electrons of atoms are loosely bound and can move freely throughout the material. This delocalization of electrons allows for easy conduction of electric current. Semiconductors. Semiconductors, like silicon or germanium, have an intermediate conductivity. Their electrical conductivity can be modified by adding impurities or applying external influences, like temperature or voltage. By controlling the conditions, semiconductors can act as conductors or insulators. Insulators, such as rubber or plastic, have tightly bound electrons, and the flow of electric current through them is extremely limited. The electrons are not free to move, making insulators poor conductors of electricity. 1. Liquids. In liquids, electrical conduction can occur in two ways: through the movement of charged particles or through ionization of dissolved ions. Electrolytic conduction. In electrolytes, such as salt water or aqueous solutions, the dissolved ions enable the flow of electric current. Positively charged ions, cations, and negatively charged ions, anions, move towards oppositely charged electrodes, allowing the conduction of electricity. Ionic conduction. Some liquids, like molten salts or liquid metals, can conduct electricity through the movement of charged particles. In these cases, the ions or charged particles can move freely, allowing for the flow of electrical current. Gases. In gases, the conduction of electricity is primarily governed by the ionization of gas molecules. When a high voltage is applied, it can strip electrons from gas molecules, resulting in the formation of charged particles called ions. The ionized gas, known as a plasma, can conduct electricity due to the presence of free-moving electrons and ions. Lightning in the atmosphere or the glowing of neon lights are examples of electrical conduction in gases. Vacuum. A vacuum is an environment devoid of matter, including particles that can carry an electrical charge. As a result, there are no free charge carriers to conduct electricity in a vacuum. However, electric fields can still exist and propagate through a vacuum, such as electromagnetic waves like radio waves, microwaves, or visible light. In summary, the conduction of electricity varies in different states of matter. Solids can conduct electricity through the movement of electrons, while liquids can conduct through ionization of dissolved ions or charged particle movement. Gases can conduct electricity through ionization or the formation of a plasma. A vacuum, lacking charged particles, does not conduct electricity but can transmit electric fields.